So this is the tutorial demonstrating how to use the pandas.DataFrame.drawing method to actually join multiple data series and form a new data frame. So the original documentation for data frame drawing is here. It says that drawing columns of another data frame. And in this specific example, we basically what we try to do is that we have a for loop here. And inside each of these for loop, we basically extract the asset ID and also the corresponding asset name. And then the asset ID will help extract the information from another data frame here to extract useful information on some other, features. And then it forms this corresponding, record or corresponding number of rows that extract corresponding to asset ID. So, for example, all the rows that has asset ID 2 will be extracted, and in this case, the name will correspond to actually Bitcoin Cash because the asset ID is 2 and name is Bitcoin Cash, and then this just extract instead of using the whole range of data which is large, we extract the specific time range according to the time step. And time step can be converted to, actually the actual date can be converted to time step, and then we are using the, we basically extract columns according to the time step. And then here we just handle some missing data. You can ignore that. And here we calculate the information that we are interested in, which is basically the log return. It is kind of the returned value or percentage money over 15. I mean not 15, but basically you have a target value here. It just used this value minus the previous one, and then you take the log operation. If you don't know, it doesn't matter for this tutorial. We just calculate, the corresponding return on the asset, right? On the asset being extracted according to the asset ID. So you can see that this is, after this whole for loop has been finished, and then you can see the log return is actually a data is a pandas series, and its value has we extracted the corresponding time step and its log return values, right? So and this data series has a name which is closed because we are basically extracting something called the rate of return. We basically I think it's this one that kind of make the name close. You can actually rename the data series to different things, but if you look at the close, it actually take out the close call. This is close, right? And then the name is close, and actually the value in this case we cannot clearly say from here because it's already extracted by the last ID in the data side. But this one is where we actually get that name close, and then the log return is really a function that compute the log return. If it matters, I can quickly go through that. It basically take your series and then compute a diff between your it basically compute the log of that series and then compute the diff based on the period that you are defining there. And then we passed in like the close price, and then the close price actually in this case let's just fill the NaN the missing value with a 0, and then we basically take out this close price and compute a log on it, and then use the consecutive column compute the difference. If you don't understand that, it doesn't matter for this tutorial. This one just it's just this time, each row corresponds to a time step, and it's a data series, and it has a bunch of values, and then its name is close. And then what we are doing here is that for inside this for loop, you can imagine that the first time that the for loop is running, it will basically extract the corresponding which is bit cache, right? That's the first time that you run this for loop. The ID will be 2, and then the asset name will be Bitcoin cache, and then you will do this type of calculation, and then you will extract the log return corresponds to Bitcoin cache, right? And then what this line does is that it will put this value being calculated for Bitcoin cache, which is a data series, and then it will put it at the this method looks like it first just put the close itself, and then it's a close Binance coin, and then close Bitcoin, close EOSIO. So let's say what's the reason that it started? Looks like it started from Binance coin and then Bitcoin and EOSIO. So you can say ignore the fact that it didn't start from Bitcoin Cash, but what it does is it takes the data series name, which is close, and then it concatenate with the corresponding asset name. And because this is the last one that after we loop through the for loop, right? That's the Dogecoin. That's why the last one is close Dogecoin, and then you got a column that is close concatenated with maker, and you can see the pattern from here onto this close Binance coin, and then the corresponding computed data series value is put here, and it's kind of using a for loop, and each time it will put one column here and give the corresponding name, and then next time the for loop will put another calculated value here and then give a name here, and so on and so forth. And my suspicion that this first column is close instead of close Bitcoin cache lies on to the fact that after computing the log return, it is basically we extracted like the first row towards the end. We threw away Um, we throw away the first data just because when you compute the difference, right? This log return, it computes the diff and the first data site in a data series. Like you know, for example, um, when you have a bunch of data series and you try to use in this case, let's just use one simple example. This is 0, 1, 2, 3, right? And then when you compute difference, this value is 1 minus 0, which is 1. This value is 2 minus 1, which is 1. 3 minus 2, which is 1. However, for this value, there's nothing ahead of it because it's the first data. That's why we need to throw this data away since it doesn't make sense. And when we do that, you know, uh, but that still doesn't explain. Um, sorry, that still doesn't explain the why there is no close Bitcoin cache. Let's see what this series is. Is it really close Bitcoin cache or something else? So let's manually just run one iteration for one calculation for the Bitcoin cache, and to do so, we can actually do something like this, and then we can extract the ID to be the number 2, right? And then we can use the asset name to be in this case, we don't need to assign an asset name yet because this will extract the corresponding value. And if we do so, um, this is our calculation for the Bitcoin cache, and that's your -0.001 all the way to 0.002551. So we can say that, just to be clear, that's exactly the value that being populated on the first column here. So it looks like the value is correctly populated. It's just a name tangling, which should be handled by this R suffix, which we specified the R suffix with used to form the right frames overlapping columns. This is used to use from the left frames overlapping columns. Okay, so the name tangling works exactly like what it described. Because the first time we join the data frame, there is no left, the so-called left um, data frame, because the first time when we join, there is only this one here, right? So you basically have this one's name that is close and then suppose that you already have the some data frame, it will treat that data frame name as you know the basically treat this all SS 21 it will have a it needs to be a combined name between close as well as the corresponding asset name. So the right suffix is always should be defined by the corresponding names. However, the left supposed to be defined by the it's supposed to be something, and that something actually does make sense until you do have you know you do have a the first time that you join here it does have this close but there's a little bit I would say some bug there because this usually the use case is like you already have some data frame and then you kind of drawing the other data frame that is K and B here, and then the data frame 1 is K and A, right? And then if there is any sort of overlap between the name, then it will start pending this suffix. And in this case, the column here, the other has a K column, and the diff here also has a K column. In this case, it starts pending left core to the K of the left data frame, and it starts pending the right suffix to the right data frame, which is the one that you try to append. In our case, it's the same thing, right? At the beginning, there's no overlap between names, so it kind of just pulls the close. And then later on, there's overlap because you can't have multiple columns called the same name as close. Then it starts pending the right suffix. That explains why we are getting such a, why we are getting, in this case, the first is just close, and the others are kind of a name suffix attached, right? So that's exactly, how it works. And now we have a concrete example of how to use this pandas data frame drawing inside a for loop. And each time you iterate through the for loop, you generate one pandas series, and then you start pending those pandas series. Kind of stack them one at a time as one column here, and then also give it a name tangling. And then the base for the drawing is assuming that they actually have the same time step, and then the drawing based on the time step.